Good morning. So dividing fractions, negative exponents, zero exponents. So let's go through these problems. And I will explain. There's a couple ways to do it. So I'll show you a variety of ways. All right. So starting off with this first one. One way to do these problems is to just rewrite it with all positive exponents. So anything that has a negative exponent, we're going to move to the reciprocal place. So I would rewrite this first problem. I leave the -2 because technically that has an exponent of 1. I leave the a, I leave the b to the 4th. In the denominator, I leave the -3. A to the -4 means it needs to go to the reciprocal place, so it belongs in the numerator, and then b to the 3rd. And then I will simplify all that. So a -2 divided by a -3 is positive 2 over 3. I will put all my a's together. A to the 1st times a to the 4th is a to the 5th. And I have b to the 4th, and in the denominator, I have b to the 3rd. Right. The next step would be then to do the division of variables. So that means I have 2 over 3. For the a's, they're all in the numerator, so they stay there. And the b's, I have b to the 4th divided by b to the 3rd. Okay. So that would be b to the 4 minus 3, which would be b to the 1st. So it would stay in the numerator because it has a positive exponent. All right, that's one way of doing it. I'm going to erase this and show you another way of doing this same problem. Okay, and that would be to just straight up do the subtracting of exponents for division. So that would give me, again, I have a -2 divided by a -3, so that is a positive 2/3. For the a's, I would have, I would have a to the 1st minus a -4. So that's going to be +4. And the b's, I would have b to the 4 minus 3. So what that would give me would be 2 over 3. A to the 1 plus 4 is a to the 5th. And b to the 4 minus 3 would be b to the 1st. Okay. Different route, same answer. All right, let's look at number 5. I could simplify. 3 goes into 3 once and into 9 3 times. Okay, so I've simplified that. So I have 1/3. And then I can deal with the variables. I have x to the -1 and x to the 1st. So I would write that x to the -1 minus, because I'm dividing these fractions, these variables, minus a 1. And then I have y to the -3 minus y to the 1st. Oops. And when I simplify that, I get 1/3. -1 take away 1 is -2. For y's, I have a -3 take away 1, that's a -4. And then I would need to rewrite this using positive exponents. 1/3 x to the -2 means it belongs in the reciprocal place, so it's down below. Y to the -4 means it needs to go to the reciprocal place, so it would be y to the 4th in the denominator. Okay. The other way of doing this problem would be to move everything to its appropriate place. So that would mean I still have the 1 and the 3. This x to the -1 belongs in the denominator. Okay. This y to the -3 belongs in the denominator. Oops. Okay. And then I'm looking at the denominator and I have x to the first, y to the first. So they all have, both have positive exponents. They stay where they are. And so what do I get here? A 1 in the numerator, a 3 in the denominator. I have x to the first times x to the first. That is x squared. And I have y to the third times y to the first. That is y to the fourth. Two different routes, same answer. All right. Some of these are easier. For example, number 3, we could just subtract. And here's what I do when I do this. I look to see where are there more variables. So for example, the x's. There's more in the denominator. So my answer will stay in the denominator and I will do 4 minus 3. And my y's, there's more in the denominator. So my answer will stay in the denominator. And that will be 2 minus 4. Oops, sorry, I wrote that backwards. 4 minus 2. There's a hidden 1 up there, so that's how I still have that 1 in the numerator. And then I would get 1 equals x, y squared. All right, here's another way to look at this problem. If I go back to the original, I could cancel. I have x to the third in the numerator, and I'm going to cancel that 3 down below. So that leaves me with just x to the first power. Y's, I have more in the denominator. So I cancel y squared, and I cancel squared 2 of them out of the denominator. And you can see here I have x to the first, y squared in the denominator. Okay. So there's a couple of ways to approach these. Sometimes one looks like it works better than another. All right, let's look at number 4 here. I can do negative divided by negative is positive, and 12 divided by 3 is 4. So I know I have a 4. If I write everything with positive exponents, I would have y to the third. And then from the denominator, this one would become a y to the first up above. I'm sorry, x to the first. This one would become a y to the first up above. And so when I look at this, everything's in the numerator. So it would be 4 x to the first, y to the fourth. All right, let's look at number 6 here. I can't reduce 3 over 2, so I'm going to keep that fraction. If I write everything with positive exponents, that means the m to the third stays where it is. The n to the -4 goes to the denominator. In the denominator, m squared stays where it is because it has a positive exponent. N to the -4 means it belongs up on top. Wrote it incorrectly, sorry. As n to the 4th. And now I can simplify this. I still have my 3 over 2 with my m's. I have them here and here. There are more m's in the numerator, so my answer is going to stay in the numerator. And 3 minus 2 is 1. My n's, I have n to the 4th over n to the 4th. When I subtract those, I get n to the 0, which is just 1. So I do not need to write that. So my answer is 3m over 2. Again, I'll leave that n to the 0 there. And I just get 3m over 2 because n to the 0 is 1. So I'm just multiplying by 1. Okay. I'll do a couple more. Let's look at number 12. Can I reduce 24 and 9? Yes, 3 is a factor of both of those. So I have my minus out in front. 3 goes into 9 3 times, 3 goes into 24 8 times. So I have a fraction, 8 over 3. I'm going to rewrite all the variables with positive exponents. So this y squared goes to the denominator, or y to the negative 2. This x to the negative 3 means it belongs in the numerator. Y to the 4th, it's a positive exponent. It stays where it is. And when I look at this, it's nice that my x's are all on top, my y's are all on the bottom. Sorry, I did this problem and you couldn't see it. I'll go back. Okay. I divided the 9 and 24 by 3. I reduced that fraction. And then I moved everything to have a positive exponent. And what I'm left with is out in front is my minus sign still. I still have my 8 over 3. I have an x to the 3rd in the numerator and a y to the 6th in the denominator. Let's look at number 15. Okay. I have a negative divided by negative, so that's positive. 10 and 15, I can reduce them both by 5. So I get a 2 over 3. I'm going to rewrite my variables all with positive exponents. So my x to the negative 4 goes down in the denominator as x to the 4th. My y to the negative 2 goes in the denominator as y squared. My x to the negative 2 goes to the reciprocal place, so it's in the numerator. And my y to the negative 3 goes from the denominator to the numerator. Now I can simplify. I still have my 2 over 3. When I look at my x's, there are more x's in the denominator, so that's where they'll stay. And I'll do 4 minus 2. That's 2. Look at my y's. There are more in the numerator, so my y's will stay in the numerator, and I'll do 3 minus 2, which will give me y to the 1st power, which I don't need to write. I don't need to write that exponent of 1. Let's look at number 16. Negative divided by negative is positive. And technically this is a 1 here. So I have a 1 over 4. And then I'm going to move everything to the reciprocal place, so that I need to. In the numerator, the x stays the same. In the denominator, my x to the negative 3 moves up to the reciprocal place. My y to the 4th stays where it is. And then I can go ahead and simplify. In the numerator, I've got 1 x times x to the 3rd. That is just x to the 4th. I don't need to write the 1 in front. I could, but I don't have to. In the denominator, I have a 4y to the 4th. Let's look at any other problems that, let's look at number 9. Okay. I have a negative 2 divided by a negative 2. So when the numerator and denominator are the same, that's a 1. Or I could say a negative divided by a negative is positive, 2 divided by 2 is 1. So I just have a 1 left. I'm going to rewrite variables, moving them to the positive position. So my x to the negative 3 belongs in the denominator. X to the negative 1 belongs in the numerator. Y to the negative 4 belongs in the numerator. And then I will simplify. With my x's, There's more in the denominator, so my answer is going to stay in the denominator, and I'm going to subtract the exponents. 3 minus 1 is 2. My y's only are in the numerator, so my answer stays just in the numerator. I can write a 1 in front, but I don't need to. It's a hidden piece of information. It's understood. Let's look at number 10. All right. On number 10, I have a minus out in front, so that's going to stay there. When I look at 4 divided by 3, I can't reduce that, so I'm just going to leave the 4 and the 3 where they are. Right? I'm going to move everything else to the reciprocal place if it has a negative exponent. So my u to the negative 3 goes to the denominator. My v to the 0, anything to the 0 power is 1. So technically, that's just a 1. When I get to the denominator, u to the negative 2, that belongs in the reciprocal place. V to the negative 3, that belongs in the reciprocal place. All right, so now I have 4 times 1, which is just 4 over 3. I look at my u's. I have more of them in the denominators. It's going to stay there, and I will subtract 3 minus 2, right, the exponents, and I just get 1. My v to the 3rd, there are no other v's, so it just stays where it is. Okay, I will do the rest of the answers, but I wanted to give you an explanation on a bunch of these, okay?